Haze significantly impairs visibility by scattering shorter wavelengths of light, resulting in a distinct bluish hue when observed against a dark backdrop and a yellowish veiling effect against lighter surroundings. Unlike mist, which imparts a grayish obscurity, haze can substantially vary in visibility conditions, dependent on factors such as the observer's position in relation to the sun. Haze is typically encountered in stable air masses and generally occupies a limited vertical expanse, reaching up to approximately 15,000 feet. Above this layer, air-to-air visibility remains unhampered, but air-to-ground visibility deteriorates markedly, particularly when facing towards the sun. Smoke, on the other hand, consists of tiny particles generated through combustion processes originating from sources such as fires and industrial activities. Over extended distances, smoke particles can transform into haze as larger particles settle and others disperse throughout the atmosphere. The adverse effects of smoke extend beyond reduced visibility, as many of its chemical compounds pose severe health risks, with carbon monoxide being a particularly dangerous component. While daylight and convective mixing can gradually ameliorate visibility when skies are clear above a surface-based layer of smoke or haze, the dissipation process is notably slower compared to fog, as it necessitates the dispersion of particulate matter by atmospheric motion. The presence of overlying clouds can impede the dissipation of smoke or haze, providing a little improvement in visibility throughout the day. Precipitation, encompassing forms such as snow, rain, and drizzle, constitutes another crucial factor influencing visibility. Heavy snowfall can obliterate visibility entirely, while rain typically reduces surface visibility to no less than 1 mile, except in brief, intense showers. Drizzle, which tends to form in stable air conditions and descends from stratiform clouds, often accompanies fog, leading to further visibility constraints. The transition from drizzle to light rain generally results in improved visibility, as larger droplets yield fewer particles per unit area, thus reducing obscurity. Blowing snow, often witnessed during strong winds, elevates loose, dry powder snow from the ground to heights exceeding 6 feet, causing reported horizontal visibility to plummet below 7 statute miles. Under extreme conditions, a whiteout effect may transpire, with the snow obscuring the sky and visibility reaching nearly zero. However, as wind speeds diminish, visibility rapidly recovers. Dust storms are characterized by robust winds carrying fine-grained soil particles into the atmosphere. With visibility plummeting to near zero with the source region, these storms, favored by daytime heating of barren terrain and a turbulent air mass conducive to dust lofting, typically necessitate surface winds exceeding 15 knots for dust mobilization. When encountering dust storms, pilots must be aware that slant range visibility may significantly differ from reported surface visibility, potentially making airfield identification challenging. Sandstorms, resembling dust storms, but on a smaller scale due to the larger and heavier sand particles involved, primarily occur in desert regions characterized by loose sand, often in dune formations. Additionally, haboobs, which are intense dust storms or sandstorms generated by cold downdrafts from thunderstorms, may emerge suddenly and pose considerable hazards. Volcanic ash, composed of minute rock particles propelled into the atmosphere by volcanic eruptions, can linger suspended for extended periods. These airborne particles pose significant threats to aviation, as they can damage jet engines, reduce visibility to zero, and cause abrasive harm to aircraft surfaces. The ingestion of volcanic ash by jet engines results in engine failure, and the abrasive impact can sandblast windows and corrode aircraft components. Therefore, pilots must exercise utmost caution when navigating airspace affected by volcanic ash.